If it is okay, then we go to the next page. This one, of course, you can find it from the textbook, but we just follow the current slide to that we have the receive power, and so that we have another way to show the receive signal power using these. About gain, in fact, previously we have the antenna gain. But right now we have the new notation to call gain of the gain of the transmitter antenna gain, and gain of the receiver. Actually, antenna gain for the transmitter and antenna gain for the receiver. If we have these, of course, we will have the new way to show the power. The power actually should be simplified to the current formula. Originally, we have the power at the transmitter. Of course, we can have the enhancement. So we have the transmitter gain. So you will amplify the gain. And of course, at the receiver side, you can amplify the gain as well. However, going through the channel, we will have loss. So loss here. All right, so we will have this simplified formula because we think amplify, so we will multiply, so we will have, example, a factor 2. Amplify, so that the label will be 2 times of the original one. So gain in the numerator and loss in the denominator. That's it. All right, so if we have these, then we can have a loss. And loss, we can put them together again. We have 3 ways to cause the loss. Path loss, and the slow fading, and the fast fading. So this one, we already have an idea. If we want to consider how will be enhanced, that says you can amplify the power. Or maybe going through the channel, you will receive the loss. So of course you have a loss. A loss right now, we put that together. So why we have a multiplication? Because we consider them simultaneously. So we have the operation of multiplication. So path loss, slow fading, and fast fading. Fading. Later we will already have the term fade. All right. So first of all, this is a concept to that we have the calculation for receive power. We can reform so that we have this one. Well, up to now it's okay. If it is okay, then we can check the individual one, path loss. So path loss, we have these. If you want to find path loss, of course, you just consider the factor here, and maybe you don't consider the others, but in fact, you can have transmitter over receiver, and so that you can have the simple one, path loss. Sorry, this is a loss from path loss. And actually, if you have the other factor, in fact, not this only, but right now we consider we incur path loss only here, so that's why we can use this directly. Because previously, if you have this, actually you have gain or something else, so it doesn't mean this one, path loss simply. But if you just have the factor path loss, you don't have antenna gain just one for each other, and you don't consider fast fading, slow fading, then you have this one. Consider a ratio, then you can find the path loss. But sometimes it is not a story like that. We have the mixture of all the loss. So you will have the other losses as well. But if you can control and solve the understand right now, you can find the loss for path loss only. So if you can use this way, then you can find the path loss. If you find the path loss, actually you can measure some parameter. How to measure? You can use field trial. Something like you try to collect the signal power, and so you have some possible formula. Of course, you can have a figure first, and so you can try to estimate what is the possible formula to govern the path loss. So use that way. I know it is a field trial, and so they can have the data. With the data, then you can try to find the formula. This formula. All right. So this formula. If let me check anything is okay. So anyone on Teams? So can you hear me?
Yeah.
Oh, okay. Thank you. I just want to make sure everything's okay. So Valencia, right?
Yeah.
Okay. Sure. We can continue. So this is the formula. How to have the formula? Of course, we need to have the data. With the data, then we will have the formula. Again, any reasons? Of course, researchers need to have the data. According to the data, then they find this formula. But they don't know the possible procedure. That's it. Well, if so, think about this. If we move it to a different scenario, so should we have the same parameters? No, right? But right now, I mean, later we will have a different scenario. But right now, we emphasize this is a path loss for free space. Alright, so right now it's free space. So I mean, if we consider a different situation, then we don't have the same form. But right now it's a free space. So it's the formula for free space. All right, so we have a carrier frequency. We have a distance again. If we consider free space. So frequency and distance. Well, for this one, well, I have something wrong. So forget it. So this one, this is a free space case to find the path loss. And we follow the formula like this. And again, find the formula from the task book. Let me know the page number. But before you go, let me have the suggestion. Write down the question, the mission I set for you. So right now, I repeat my question. Find the page number from the task book for this formula. So try to write it down. At least I have an instruction. Try to write it down, and so that you can keep in mind the mission for you. Or otherwise, you don't know, and then you don't have any idea, so you cannot find it. At least, let me try to do. Write down the question. Find the page number. Same for me. Find the page number. Of this equation. And of course, have 1 minute to look at this formula.